Hello, in this lecture we will find the radius of a circle. In the picture we have a circle, and the center of this circle is at point O, and the chord AD or string AD equals to 10 units. Chord or string BC equals to 5 units. Chord or string BC equals to 5 units, and this angle equals to 90 degrees, and we want to find out the radius of this circle. Okay, first of all I will explain you what is a peripheral angle. The definition of a peripheral angle a peripheral angle is an angle inside the circle its vertex is on the circle, and its columns are chords in the circle, chords or strings in the circle. So I will read the definition of a peripheral angle again. A peripheral angle is an angle inside a circle. Its vertex is on the circle, and its columns are chords or strings in the circle. I will give you an example of a peripheral angle in order to clarify the term. angle alpha is a peripheral angle because it is inside the circle, inside the red circle. Its vertex is at point A, and point A is also a point on the circle itself, and curve AB of angle alpha is string or chord in the circle, and also curve AC of angle alpha is chord or string in the circle. And also angle alpha rests on chord BC in the circle. Okay, chord BC. And so a peripheral angle is an angle inside the circle. Its vertex is on the circle, and point A is on the circle, and point A is also the vertex of angle alpha, and its curves are chords in the circle. So string AB curve AB of angle alpha is string or chord in the circle, and curve AC of angle alpha is string in the circle. And also angle alpha rests on string BC in the circle. So that is the definition of a peripheral angle. In the next step, we will draw a chord or string through points A and O. We draw a string or chord through points A and O, and you should remember that point O is the center of this circle, and we will call to the touching point between the string and the circle point M. Again, point M is the touching point between the chord or the string that I drew to the circle. Okay. Actually, chord AM is the diameter of this circle. I will write it down. Chord or string AM is the diameter of this circle. Because it passes through point O, that is the center of this circle. So chord AM is the diameter of the circle because it passes through point O, and point O is the center of this circle. So chord AM is the diameter of the circle because it passes through the center of the circle. Point O, that is the center of the circle. So I will read again the things that I wrote. Chord AM is the diameter of the circle because it passes through point O, and point O is the diameter of the circle. For that reason, chord AM is the diameter of this circle. In the next step, we will connect together by a straight line points M and D. Actually, we have a rule, I will call it rule number 1. Rule number 1 states that a peripheral angle that rests on the diameter of a circle equals to 90 degrees. I will read again rule number 1. Rule number 1 states that a peripheral angle that rests on the diameter of a circle equals to 90 degrees. So I will show you an example of a peripheral angle that rests on the diameter of a circle. Suppose that cord or string AB is the diameter of this circle. Okay, any peripheral angle that rests on this diameter AB will be equal to 90 degrees according to rule number 1. So if we have a peripheral angle angle ACB is a peripheral angle, and as you can see from the drawing, it rests on string AB that is also the diameter of this circle. So according to rule number 1, it equals to 90 degrees. Okay? So peripheral angle ACB equals to 90 degrees because according to rule number 1, any peripheral angle that rests on the diameter of a circle equals to 90 degrees, and angle ACB rests on AB that is the diameter of this circle, therefore it equals to 90 degrees. Okay, so I'll write it down. Peripheral angle ACB rests on chord AB chord AB that is the diameter of the circle. Therefore, according to rule number 1, it equals to 90 degrees. Equals to 90 degrees. So I will read again what I want. peripheral angle ACB rests on chord AB, and chord AB is the diameter of this circle. Therefore, according to rule number 1, it equals to 90 degrees. Okay? So we can use rule number 1 in our circle, or we can implement rule number 1 in our circle. Because angle ADM rests on chord AM. I'll write it down. Angle ADM rests on chord AM that is the diameter of the circle. AM is the diameter of the circle. Therefore, according to rule number 1, it equals to 90 degrees. So I read again what I wrote. Angle ADM, this angle ADM rests on chord AM, and chord AM is the diameter of the circle. Therefore, according to rule number 1, angle ADM equals to 90 degrees. So, this angle is 90 degrees. Now we will define angle AMD as alpha. In the right triangle AMD, we will define angle AMD as alpha. Angle AMD is defined as alpha, and angle MAD will be defined as beta. Okay, so in the right triangle AMD, angle AMD equals to alpha, and angle MAD equals to beta. In the next step, we will connect together by a straight line points A and B. We have rule number 2. That states that if two peripheral angles or we can say peripheral angles peripheral angles that rests on the same chord equal to each other. So I will read again rule number 2. Rule number 2 states that peripheral angle or peripheral angles that rest on the same chord, or you can add same chord or same arc, equal to each other again. Peripheral angles that rest on the same chord or same arc equal to each other. So I will show you an example of rule number 2. If we have two peripheral angles, here peripheral angle alpha rests on chord BC, and we have another peripheral angle that also equals to alpha that rests on the same chord BC. So we also have another peripheral angle beta, and peripheral angle beta also rests on the same chord or same string BC. So according to rule number 2, they are equal to each other. Again, rule number 1 states that peripheral angles that rest on the same chord or same arc equal to each other. So we have here two peripheral angles, angle alpha and angle beta, that rest on the same chord BC. So according to rule number 2, they are equal to each other, that is to say alpha equals to beta. Okay, so I write it down. So we have two peripheral angles, alpha and beta, that rest on the same chord BC. Alpha rests on chord BC, also beta rests on the same chord BC. So according to rule number 2, they are equal to each other. they are equal to each other. That is to say, angle alpha equals to angle beta. So I will read again what I wrote. Peripheral angles alpha and beta rest on the same chord BC. As you can see from the drawing, peripheral angle alpha rests on chord BC, and also peripheral angle beta rests on the same chord BC. So according to rule number 2, they are equal to each other. That is to say, alpha equals to beta. Okay? So according to rule number 2, because of the fact that those two peripheral angles, alpha and beta, rest on the same chord, chord BC, they are equal to each other. That is to say, alpha equals to beta. Okay, so that is the example of rule number 2. We actually can use rule number 2 in our circle. We can implement rule number 2 in our circle, because actually we have angle AMD that equals to alpha, and angle AMD rests on chord AD, and angle ABD also rests on the same chord. So we have here two peripheral angles that rest on the same chord AD. Angle AMD that equals to alpha rests on chord AD, and also angle ABD rests on the same chord AD. So according to rule number 2, they are equal to each other. That is to say, angle ABD also equals to alpha. Okay, so I will write it down. So angle ABD that equals to alpha rests on chord AD. So I will read what I wrote. angle ABD that equals to alpha rests on chord AD. As you can see from the drawing, angle ABD that again angle AMD that equals to alpha rests on chord AD. Angle AMD equals to alpha and it rests on chord AD. And angle ABD rests on the same chord AD. Angle ABD rests on the same chord AD. Therefore, according to rule number 2, they are equal to each other. That is to say, angle ABD equals to alpha. They are equal to each other. That is to say, angle ABD also equals to alpha. Angle ABD equals to alpha. Okay, so this angle is angle alpha. Angle ABD equals to alpha. Okay, again we have angle AMD that equals to alpha and rests on chord AD. We also have angle ABD that also rests on the same chord AD. So according to rule number 2, they are equal to each other. That is to say, angle ABD equals to angle alpha. Okay? We will return to the right triangle AMD. As you have already know, the sum of the angles in any triangle equals to 180 degrees, and especially it is true for the right triangle AMD. The sum of the angles in the right triangle AMD equals to 180 degrees. So I write it down that alpha plus beta plus 90 degrees equals to 180 degrees. So this will be our first equation. It states that the sum of the angles in the right triangle AMD equals to 180 degrees, or alpha plus beta plus 90 degrees equals to 180 degrees. Okay, our first equation states that the sum of the angles in the right triangle ABD equals to alpha plus beta plus 90 degrees. So alpha plus beta plus 90 degrees, that is the sum of the angles in the right triangle AMD, equals to 180 degrees. We will subtract 90 degrees from equation number 1. So we subtracted 90 degrees from equation number 1. Alpha plus beta plus 90 degrees minus 90 degrees equals to alpha plus beta, and 180 degrees minus 90 degrees equals to 90 degrees. Now we subtract alpha from equation number 1. So we subtracted alpha from equation number 1. Alpha plus beta minus alpha equals to beta. 90 degrees minus alpha equals to 90 degrees minus alpha. So equation number 1 states that beta equals to 90 degrees minus alpha. We will define angle B. First of all, the vertex of the right triangle will be defined as L, and we will define angle BAL as X. Okay, angle BAL equals to X. In the right triangle ABL, angle BAL is defined as X. The sum of the angles in any triangle equals to 180 degrees, and especially in the right triangle ABL, the sum of its angles equals to 180 degrees. So we will create the second equation that states that the sum of the angles in the right triangle ABL equals to 180 degrees. So equation number 2 will be alpha plus beta plus 90 degrees So equation number 2 states that the sum of the angles in the right triangle ABL equals to 180 degrees. So alpha plus x plus 90 degrees equals to 180 degrees. Okay, alpha plus x plus 90 degrees equals to 180 degrees. We'll subtract from equation number 2 90 degrees. So we subtracted 90 degrees from equation number 2. alpha plus x plus 90 degrees minus 90 degrees equals to alpha plus x, and 180 degrees minus 90 degrees equals to 90 degrees. Now we subtract alpha from equation number 2. So we subtracted alpha from equation number 2. Alpha plus x minus alpha equals to x, and 90 degrees minus alpha equals to 90 degrees minus alpha. So actually we have equation number 2 that states that x equals to 90 degrees minus alpha, but equation number 1 states that beta equals to 90 degrees minus alpha. Okay, so I will write it down. So equation number 2 states that x equals 90 degrees minus alpha, and equation number 1 states that beta equals 90 degrees minus alpha. So we can integrate between equation number 2 and 1, and we will find out the value of x. So from one side we have beta that equals to 90 degrees minus alpha. Yes. Equation number 1 states that beta equals 90 degrees minus alpha. But according to equation number 2, 90 degrees minus alpha equals to x. So we can add in this equality that 90 degrees minus alpha equals to x. Okay? So from this equality we can deduce that x equals to beta. Okay? X equals to beta. Okay, x equals to beta, and actually we can change the value of x to beta, because x equals to beta, Okay, angle ABL equals to beta. Okay, we actually have rule number 3. Rule number 3 states that equal peripheral angles rests on equal chords. On equal chords or equal arcs. So I will read again rule number 2, no, rule number 3. Rule number 3 states that equal peripheral angles rests on equal chords or equal arcs. So I will give you an example in order to clarify rule number 3. So actually if we have two angles that equal between them, for example we have angle alpha we have angle alpha in the blue color that rests on chord BC. We also have another angle alpha that rests on chord EF. So the black angle alpha, or maybe I will do it in the red color in order that you can see it. So the red angle alpha rests on chord EF. So because of the fact that those two angles are equal to each other, therefore according to rule number 3, they rest on equal chords. That is to say, BC equals to EF. Okay, so I write it down. The two angles are equal to each other. both of them equal to angle alpha. The two angles are equal to each other. Therefore, according to rule number 3, they rest on equal chords. That is to say, BC equals to EF. So I will read again what I wrote. The two angles the two peripheral angles are equal to each other, both of them equal to alpha. Therefore, according to rule number 3, they rest on equal chords. That is to say, BC equals to EF. Okay, we can use this rule number 3 in our circle, or we can implement rule number 3 in our circle. We have angle peripheral angle ABC that equals to beta, and it rests on chord BC. Again, peripheral angle BAC, okay? Peripheral angle BAC equals to beta. Peripheral angle BAC equals to beta. Okay, peripheral angle BAC equals to beta, and it rests on chord BC. Peripheral angle MAD equals also to beta, and it rests on chord MD. Peripheral angle MAD equals to beta. Peripheral angle MAD equals to beta, and it rests on chord MD. Peripheral angle MAD that equals to beta rests on chord MD. So because of the fact that those two angles are equal to each other, both of them equal to beta, therefore, according to rule number 3, they rest on equal chords. That is to say, BC equals to MD. Okay? So because of the fact that those two angles are equal to each other, okay, those two angles are equal to each other. So according to rule number 3, they rest on equal chords. That is to say, BC equals to MD. So I read again what I wrote. So peripheral angle MAD peripheral angle MAD peripheral angle MAD equals to beta. Peripheral angle MAD equals to beta, and it rests on chord MD. While peripheral angle BAC also equals to beta, and it rests on chord BC. So because of the fact that those two angles are equal to each other, according to rule number 3, they rest on equal chords. That is to say, BC equals to MD. Very simple. Again, because of the fact that those two angles are equal to each other, both of them equals to beta, according to rule number 3, they rest on equal chords. That is to say, BC equals to MD. That's all. Okay? So, we know that BC equals to MD. But according to the question itself, BC equals to 5 units. Okay? According to rule number 3, BC equals to MD. Okay? But it is given us in the question that BC equals to 5 units. Okay, BC equals to 5 units. It is given us in the question. So we can write here that BC equals to 5 units. So from this equality, we can deduce that MD equals to 5 units. Okay, MD equals to 5 units. Okay. So we can write here that MD equals to 5 units. So now I will draw triangle AMD again. So this is right triangle AMD, side AD equals to 10 units, side MD equals to 5 units, and AM we found in the beginning of the lecture, we arrived to the conclusion that AM is the diameter of this circle because of the fact that it passes through point O, that is the center of this circle. Therefore, AM is the diameter of this circle. So, actually, we can name AM D, abbreviation for diameter. Okay. Okay, AM equals to D. It is abbreviation for diameter. We can use the Pythagorean theorem in order to find out the value of D. Okay. So the Pythagorean theorem states in a right triangle, the Pythagorean theorem correct only on right triangles. If it is not right triangle, you cannot use the Pythagorean theorem. In a right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. So I will read again the Pythagorean theorem. In a right triangle, again, the Pythagorean theorem apply only on right triangles. In a right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. Okay, so the square of the hypotenuse equals to the sum of the squares of the perpendiculars. So we actually will implement, or we will use or implement the Pythagorean theorem in our right triangle. Okay, so the square of the hypotenuse is AM square. This will be our third equation. AM square equals to the sum of the squares of the perpendiculars, equals to AD square plus MD square. Okay. AM square, the square of the hypotenuse, equals to the sum of the squares of the perpendiculars, equals to AD square plus MD square. But we know that AM equals to D, AD equals to 10, and MD equals to 5 units. Okay, we know, actually you can substitute AM by D, AD by 10 units, and MD by 5 units. Okay. Okay, so we got that D square equals to 10 square plus 5 square. Okay, 10 square is 100 plus 5 square is 25. 100 plus 25 equals to 125. I write it down. Okay, this square equals to 125. Now we will take a root out of equation number 3. Okay, D equals to root of 125. 125 equals to 25 times 5. I write it down. Okay, D equals to 25 times 5. 25 times 5 equals 125. So we substituted 25, 125, 25 times 5. Now we can separate the roots to two roots according to the rule that the root a times b equals to root a times root b. We have the rule that the root of a times b equals to root a times root b, so root of 25 times 5 will be equal to root 25 times root 5. Okay, so I write it down. Okay, we separated root 25 times 5 to two roots, root 25 times root 5, according to the equality that the root of a times b equals root a times root b. Root of 25 equals to 5, so I write it down. Again, root of 25 equals to 5, so we got that d equals to 5 times root 5, but we know that d is the diameter of the circle, it equals to am, and am is the diameter of the circle, so d also is the diameter of the circle. And in general, the diameter of any circle in the world equals to 2 times the radius. So we will create the fourth equation that states that the diameter of any circle equals to 2 times the radius of a circle. Okay, it is a general truth, especially it is true in our circle. The diameter of our circle equals to 2 times the radius. So we know that d equals to 5 times root 5, so we can substitute d by 5 times root 5. So we substituted d by 5 times root 5. We got that 5 times root 5 equals to 2 times the radius. We will divide by 2 equation number 4, and we will get the radius of the circle. So we divided equation number 4 by 2. We got that the radius of the circle equals to 5 times root 5 over 2 units. Or in terms of numbers, we can write that r equals to 5.59 units. So actually, if we want to write the radius in terms of numbers, instead of 5 times root 5 over 2, we can write that the radius of the circle equals to 5.59 units. Okay, again, the answer to the question is that the radius of this circle equals to 5 times root 5 over 2 units, or in terms of numbers we can say that the radius of this circle equals to 5.59 units. Okay, so now I will summarize the lecture. Actually, we wanted to find out the radius of this circle, and we know that chord or string AD equals to 10 units, string BC in the circle equals to 5 units, and the center of this circle is at point O, and this angle is 90 degrees, equals to 90 degrees, and we want to find out the radius of this circle. Okay, first of all, I explained you the theorem of a peripheral angle. Actually, a peripheral angle is an angle inside the circle. Its vertex is on the circle, and its curves are strings in the circle. Okay, that is the definition of a peripheral angle. Again, the definition of a peripheral angle. A peripheral angle is an angle inside a circle. Its vertex is on the circle, and its curves are chords in the circle. So I gave you an example of a peripheral angle. Angle alpha is a peripheral angle because, first of all, angle alpha is inside the red circle, and the vertex of angle alpha is at point A, and point A is also a point on the circle itself, and the curve AB of angle alpha is string or chord in this circle, and also curve AC of angle alpha is a string in this circle, and angle alpha rests on chord BC in the circle. Okay, so that is the definition of a peripheral angle, and in the first step, we drew a string or chord through points A and O. Okay, we draw a chord through point A and O, and actually you should remember that point O is the center of the circle, and we call to the touching point of the string with the circle point M. Actually, chord AM is the diameter of the circle because it passes through the center of this circle. It passes through point O, that is the center of this circle. That for that reason, chord AM is the diameter of this circle. Any chord, any string that passes through the center of a circle is defined as the diameter of that circle, and especially chord AM that passes through the center of the circle for point O. For that reason, chord AM is the diameter of this circle. Okay, and we also have rule number 1 that states that a peripheral angle that rests on the diameter of a circle equals to 90 degrees. Okay, I gave you an example of rule number 1. We have, suppose that AB is the diameter of the red circle, and we have angle ACB that rests on AB, that is the diameter of this circle. So, according to rule number 1, any peripheral angle that rests on the diameter of a circle equals to 90 degrees. Therefore, according to rule number 1, angle ACB equals to 90 degrees. And any other peripheral angle that rests on this diameter AB will be equal to 90 degrees. Okay, that is the explanation for rule number 1. We implemented rule number 1 in our circle because we have angle ADM that rests on chord AM, and AM is the diameter of this circle. For that reason, according to rule number 1, angle ADM is a right angle. It equals to 90 degrees. Okay? In the next step, we actually focused on the right triangle ADM. We defined angle DMA as alpha and angle MAD as beta. And we actually have rule number 2 that states that peripheral angles that rest on the same chord or same arc are equal to each other. Okay, peripheral angles that rest on the same chord or same arc are equal to each other. So I gave you an example of rule number 2. We have two peripheral angles alpha and beta that rest on the same chord BC. So according to rule number 2, they are equal to each other, that is to say alpha equals to beta. Okay? Those two peripheral angles alpha and beta rest on the same chord BC. Therefore, according to rule number 2, they are equal to each other. That is to say, alpha equals to beta. Okay? So, we implemented rule number 2 in our circle. We have angle AMD that equals to alpha, according to our definition. And we also have angle ABD that rests on the same chord AD. Actually, angle AMD that equals to alpha rests on chord AD, and angle ABD rests on the same chord AD. So, according to rule number 2, because of the fact that angle ABD rests on the same chord as angle AMD that equals to alpha, according to rule number 2, they are equal to each other. So angle ABD equals to alpha, according to rule number 2. Because of the fact that those two peripheral angles rest on the same chord AD, they are equal to each other. That is to say, angle ABD equals to angle alpha. Okay, so I wrote here that angle ABD equals to alpha. Okay. Then we return back to the right triangle AMD. We know that the sum of the angles in any right triangle equals to 180 degrees, and this, especially in the right triangle AMD, the sum of its angles equals to 180 degrees. So alpha plus beta plus 90 degrees equals to 180 degrees. Okay, we have equation number 1 that states that alpha plus beta plus 90 degrees equals to 180 degrees. For equation number 1, we got that beta equals to 90 degrees minus alpha. And in the right triangle ABL, we defined angle BAL as x. And we have already found out that angle ABL equals to alpha, and angle BAL is defined as x. And we know that the sum of the angles in the right triangle ABL equals to 180 degrees. So x plus alpha plus 90 degrees equals to 180 degrees. So equation number 2 states that x plus alpha plus 90 degrees equals to 180 degrees. So for equation number 1, we got that x equals to 90 degrees minus alpha. So actually, equation number 2 states that x equals to 90 degrees minus alpha, but for equation number 1, we have already know that beta also equals to 90 degrees minus alpha. So we can integrate those two equations together. Here beta equals to 90 degrees minus alpha is equation number 1, and 90 degrees minus alpha that equals to x is equation number 2. So we can add here that 90 degrees minus alpha equals to x according to equation number 2, and beta equals to 90 degrees minus alpha according to equation number 1. So we integrated those two equations together, and we got to the conclusion that beta equals to x, or x equals to beta. Okay, so actually instead of x, instead angle BAL we defined it as x, and instead of x we can write here beta because x equals to beta. Okay, so we have angle BAL that equals to beta, and also angle MAD also equals to beta. And according to rule number 3, equal peripheral angles rests on equal chords or equal arcs. So I show you an example of rule number 3. If we have two equal peripheral angles, we have the blue alpha and the red alpha, those two angles are equal to each other. Therefore, according to rule number 3, they rest on equal chords. That is to say, BC equals to EF. Very simple. Okay? If we have two peripheral angles that are equal to each other, then they rest on equal chords. In this example, those two peripheral angles are equal to each other, and so according to rule number 3, they rest on equal chords. That is to say, BC equals to EF. Okay, that is the explanation of rule number 3. We implemented rule number 3 in our circle because actually we have two peripheral angles that equal to beta. This peripheral angle equals to beta, and this peripheral angle also equals to beta. So according to rule number 3, they rest on equal chords. That is to say, BC equals to MD. Okay? In this drawing, we have two peripheral angles that equal to each other. This angle is beta and this angle is also beta. So, according to rule number 3, they rest on equal chords. That is to say, BC equals to MD. That's all. Okay? So we know that BC equals to MD, but it is given us in the question that BC equals to 5 units. Okay? According to rule number 3, BC equals to MD, but it is given us in the question that BC equals to 5 units. Okay, BC equals to 5 units. So from this equality, we can deduce that MD equals to 5 units to MD equals to 5 units. So we alter that MD equals to 5 units, and I draw the right triangle AMD again. Side AD of the right triangle equals to 10 units, side MD equals to 5 units, and AM is the diameter of the circle. At the beginning of the lecture, we got to the conclusion that AM is the diameter of this circle. So, we named AM D, we defined it as D, that is the abbreviation for diameter, and we can use the Pythagorean theorem in order to find out the hypotenuse of this right triangle, that is also equals to D. Actually, the Pythagorean theorem states that in a right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. Okay, so we can implement the Pythagorean theorem in our right triangle. The square of the hypotenuse is AM square. It equals to the sum of the square of the perpendiculars. AM square equals to AD square plus MD square. Okay, therefore the question states that AM square equals to AD square plus MD square. But we know that AM equals to D, AD equals to 10 units, and MD equals to 5 units. Okay, so we can put the data in the further question, and we put the data in the further question, and we found out that d equals to 5 times root 5. But we also have the general equation that states that the diameter of any circle equals to 2 times the radius. That is our fourth equation. It is true for any triangle or for any circle, especially in our circle. So we can substitute d by 5 times root 5. We substituted d by 5 times root 5 and we got that the radius of this circle equals to 5 times root 5 over 2 units. So the radius of this circle equals to 5.59 units. Okay, thank you very much.